Hey everyone, welcome to my YouTube channel. Before starting the video, just repeat after me that Google, Facebook, Amazon and all FAANG companies. Okay, the problem asked in these companies are super easy. Yes, super easy. Because we are going to prove all the myth wrong in this company, in this video. There's a very bad or there's a very wrong myth that, to solve these problems, to solve the problems of FAANG, we need dynamic programming. Okay, we need the high knowledge of graph. No, there's a very wrong myth and we're gonna prove all these myths wrong in this video. Okay, and at the end of video you itself write the comment that yeah, the problems we have done, the problems which are asked in FAANG companies, we're gonna solve this that problems. Okay, those problems are super easy and we can solve any problem of binary search. Okay, so let's start the video. Okay, let's start the video. So first, before starting the video, our first topic is, when do we apply binary search? Okay, when do we apply binary search? When do we apply binary search? This is the first question. Okay, suppose you have seen the question. Okay, then you need to just figure out, okay, I need to apply binary search in this or not. Definitely. So when do we apply binary search? The first point, whenever you see sorted array or sorted matrix or sorted list, you know my point. Whenever you see sorted array or matrix or list, sorted means either in increasing order or decreasing order, or we can call it as non-increasing. Okay, at that time just try to solve the problem using binary search, and in the most of the cases the problem got solved. Okay, this is the first case. The second scenario, where the direct sorted list or array or matrix is not given to you. Okay, but you need to find that there is a continuous sequence of numbers, there's a continuous sequence is going on of characters or anything, but there should be a continuous sequence. For example, okay, so second thing is continuous sequence. Okay, so for example is, for example, sqrt of x is square root of a number. Okay, square root of a number. Suppose you need to find square root of a number 14. Okay, using binary search. Now in this there is no array is given, no matrix or no list is given. So how you can figure out, okay, I need to apply binary search in this. So how you figure out that, you can see here. How you will calculate the square root? Okay, if the number, okay, from 1 to 14 upon 2, that is 7. If the square of these numbers are equals to 14, 1 into 1 equals 14, no. 2 into 2, no. 3 into 3, no. 7 into 7, no. 5 into 5, no. Okay, if you want to find out the integer value, then it is 3 into 3, 9. Okay, 4 into 4, 16. So definitely between 3 and 4. Okay, so just see carefully, we are following a specific sequence, continuous sequence. We are checking 1, 2, 3, 4. Suppose you need to find out the square root of 49. Then 1, 2, 3, 4, 5, 6, 7. Okay, so in that you are following a continuous sequence. In that case, you should apply binary search. Getting my point? So in that case, you need to apply binary search. Okay, this is the first, and you need to know, because we are going to solve the problems and you should know, like, okay, when do we apply binary search? Okay, so this is one thing. Now let's solve the problem. Our first problem is, okay, now let's see our first problem, that is ceiling of a number. Ceiling of a number. Fine. Suppose an array is given to us. 2, 3, 4, 5, 10, 12, 13, 19, 21, 25 and 30. Okay, this is the array given to us. Okay, and before starting it, see here I have taken increasing order array. Okay, increasing order sorted array. Okay, same you can apply for decreasing order. Just you need to change the condition. In the binary search video we have done this program. Okay, in the binary search video we have done this program. Okay, and it is an increasing order array. You need to find the index of the 16, and I'm hoping that the same thing, the same concept you will apply for decreasing order. Okay, if not, then let me do it for you. 30, 25, 21, 16, 15, 12, 10, 6, 5, 3. Okay, so this is the decreasing order. This is the decreasing order. First step is you need to calculate the mid element. What is mid? 0 plus 9 upon 2. Okay, 4.5 in integer it is 4. Fine. Now you need to check the condition if target is greater than equal to ARR of mid. Okay, ARR of mid. What is the target? Target is our 16. ARR of mid. What is mid? 4. ARR of mid is 0, 1, 2, 3, 4. That is 15. It is greater. Condition true. Okay. Now if my target is greater than ARR of mid, then there is no point to check after this, because after this, after my mid, all the elements are smaller. See, if my target is greater than this mid element, then definitely my target is greater than all these elements, because it is decreasing order array, sorted array. So there is no point to check in this. Okay, it is start, it is end. Now the end shifted to mid minus 1. That is mid minus 1. So this condition apply here, this condition apply here. Rest all is same. And this is what binary search in decreasing order. Get my point? Okay, so this is what in decreasing order. Just you need to change these conditions. Okay, so now let's do our problem. Let's do a problem. Ceiling of a number. So what it means? Ceiling of a number means the smallest number, okay, which is greater or equals to target. Okay, our target is, suppose our target is suppose our target is 21. Okay, so as per the definition, the smallest number which is greater or equals to, is 21 is present in the array or not? Yes, it is present. If it is present, then you need to find the index of this element. Okay, simple. Similarly, this example. Okay, don't worry, I'll publish this solution in the notes. Okay, so similarly, in increasing order, you need to find the index. Okay, if suppose my target will be 24, then 24 is not present in the array. 24 is not present in the array. Okay, so the answer will be 25. The answer will be 25. Okay, because the smallest number which is greater than or equals to 25 is the smallest number which is greater than target 24 or equals to. There is no equals to. So the another condition, the smallest number which is greater than, this is 25 is the smallest number which is greater than 24. Getting my point? This is the ceiling. So we need to find out, and there is only one change. There is only one change, and that is a beauty. See here. Just replace it with start, and you get the answer. How? Let's break the problem in step by step. Let's break the problem. Okay. So our target is 24. Okay. First step. First step is find out mid. Find mid. What is mid? Start plus and minus start upon 2. What is start? Okay. So condition first, start less than equals n, start equals 0 and equals 9. Okay. Same condition. This and start and end. Okay. So start equals 0 and end equals ARR of length minus 1. Length is 10, 10 minus 1, that is 9. Okay. So start 0 plus 9 minus 0 upon 2, which is 4.5. 4 in integer. Okay. This is the mid. Now the second step is check. Check whether target is less than, greater than, or equals to ARR of mid. What is target? Target is 24. ARR of mid. Mid is 4. ARR of mid is 0, 1, 2, 3, 4, 10. Okay. So in this case, target is greater. If the target is greater, then start equals mid plus 1. Same thing. Start equal mid plus 1. Okay. I'm comparing. Same thing. Now start equal mid plus 1. So what is the new start is? What is mid? 4. Mid is 4 plus 1, which is 5. So this is a new start. This is our new start. Second case. Again loop. See, this condition got true. Start equal mid plus 1. Fine. Again check the condition. What is the condition? While start less than equals end. What is the start? 5 and 9. Condition true. Okay. Find out again mid. What is the mid? Now start is start plus and minus start upon 2. What is the start? 5 plus 9 minus 5 upon 2. 4 upon 2, 2, 2 plus 5, 7. Okay, 7 is our new mid. Fine, 7 is our new mid. Okay, 7 is our new mid. So our mid is in the second case 7. Okay, now again check if my target is less than, greater than, or equals to ARR of mid. What is my target? Target is 24, right? 24 na? 24. Okay, 24. Okay, ARR of mid. What is mid? 7. ARR of mid is 0, 1, 2, 3, 4, 5, 6, 7, 19. Okay, 0, 1, 2, 3, 4, 5, 6, 7. Okay, 19. Still 24 is greater. If it is still 24 greater, then start equals mid plus 1. What is mid? 7 plus 1, 8 is our new start. Okay. Third time. Condition. While start less than equals end. What is start? 8. What is end? 9. Okay. Condition got true. Okay. Calculate mid. What is mid? Start plus and minus start upon 2. Start plus and minus start upon 2, which is 17 upon 2, which is 8 in integer. Okay. Check. If my target is less than, greater than, or equals to ARR of mid. What is target? 24. What is ARR of mid? ARR of 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. 21. Still less than. Then what is, if my target is greater, right? Target is greater. So if my still target is greater, if my target is greater than start equals mid plus 1. Again, start equals mid plus 1. What is mid? Mid is 8. 8 plus 1, which is 9. Okay. My start equals 9. Fine. Again check. Let me again copy this. Target 24. Okay, again check. Again check my while condition. Start less than equals end. What is start? 9. 9 less than equals 9. Condition true. Okay, my start is this now. See, this is the start, this is end initially. Then it become, what is my new start? The start is 9, end is again 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The start is 9, end is also 9. Start, end. Okay. Start is 9, end is 9. Fine. So again, now check if my target is less than, greater than, or equal to ARR of mid. What is my target? Target is 24. ARR of mid is 9. That is 25. ARR of 9. It is less than. If my target is less than, then AR and equal mid minus 1. Now change the end and equal mid minus 1. What is mid? 9 minus 1, which is 8. Our new end. So this is the end. Now end become this. It is the mid only. What is mid? See. Okay, we haven't calculated mid. So mid equals 9 plus 9 minus 9 upon 2, which is 9. Okay, 9 is our new mid. So this is start, this is end, and this is only a mid. Fine. So mid, ARR of mid. Okay, so we have calculated the check. Then target is less than mid, ARR of mid. That means end is shifted here. Okay, end is shifted, that mid minus 1, so end becomes 8. So this is end and this is start. Okay. Again check. While start less than equals end. What is the end? What is the start? 9. What is end? 8. Okay, the start is 9 only. Condition false. Okay, if condition false, comes out of the for loop, return minus 1 initially. Let's replace this with start. What is start? 9. 9 is the start. Okay, ARR of 9, which is 25. Okay, what the definition says is smallest number which is greater or equals to 25 is the smallest number which is greater than our target, which is 24. Okay, 25 is the smallest number which is greater than or equals to target. Okay, and what we get? Return is start. What is the start? 9. What is ARR of 9? 25. Return 9. How many changes? Just one change. Start. Okay. Suppose 24. Let's run it. 8. See here. The array size is different. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8. We can print the index element. Okay. We can print the element. No worries. 25. Okay. So this is ceiling of a number. Ceiling of a number. This is. Now, this is the first problem. Second problem. Okay, you got it right? You got it, no? Don't need dynamic programming, yeah. We'll see a great problems later. In this video only. Okay, so just one change. Start. Okay, just one change. We've already done this program. The next problem is floor of a number. Reverse. Suppose the array is given to you is 2, 3, 5, 10, 16, 21, 25, 32, 48. Okay, what is the floor of a number? Ceiling is smallest number greater or equals to target. Ceiling is smallest number greater than or equals to target. Floor is greatest number. Okay, which is reverse, right? Greatest number which is less than or equal to target. Which is less than or equals to target. Okay. Now what is the one change you need? So it's simple, yaar. And just one change. 24, right? Now what is the greatest number which is less than 21? 21 is the greatest number which is less than 24 because there is no number which is equals to 24. So answer will be 21. Okay, so let's debug. Okay, let's debug. Control will stop here. Okay, next start is zero and is 9. Okay, fine. Mid is 4. Okay, target definitely. What is the target? Target is 24. ARR of mid is right click, inspect. ARR of mid is 4. 0, 1, 2, 3, 4, 12. Obviously target is greater. Start equals mid plus 1. What is mid? 4. 4 plus 1, 5. Start definitely be 5. What is the start? Start is, come on, 5. Okay, and is still same, 9. Fine. Okay, then it should be a 7, right? Yeah, 7. Okay, what is the target? Target 24. ARR of 7, 0, 1, 2, 3, 4, 5, 6, 7, 21. Still target is greater. Mid plus 1. What is the mid? Mid is 7. 7 plus 1, 8. So the new start will be the 8. What is the 8? What is the new start? New start will be 8. Okay. Okay, new start will be 8. And is 9 only. Okay, so mid is 8 plus 9 upon 2. 8 plus 9, 17 upon 2. That is 17 upon 2 is 8 only. Okay, mid is 8. Now target, which is 24. Target 24 and ARR of 8. What is ARR of 8? 0, 1, 2, 3, 4, 5, 6, 7, 8. ARR of 8 is 25. That means this condition got failed. 24 is not greater than 25, right? 24 is less than 25. So it comes here, and now this condition got true. What is the end? End was 9 only, right? End is 9. Now end become mid minus 1. What is the mid? Mid is our 8. So 8 minus 1. 8 minus 1, that is 7. 7. Okay. Now start is 8 only, but end becomes 7 because using this condition. If start is greater than, start is 8, end is less. So condition got failed. Condition got failed in ARR of end. Where is the end here? End is at this position. Okay, we have executed this condition, so end become 8 minus 1, that is 7. ARR of 7 is 21, which is our answer. That 21 is the greatest number, which is less than 24. 24 comes here somewhere, so it is the greatest number which is less than 24. Okay, now wait, there is a problem. There is a problem in ceiling and floor of a number. Okay, now what is the problem? Suppose if my target element is 50. If my target element is 50, that means if my target element exceeds the last number. Get my point? It is the last number 30. Okay, my target element is 50, which is not present in this. Okay, but it exceeds the last number. Okay, if my target element is not present in this or not in the range in between, suppose if my target element is 24, so it is a range in between 21 25. If my target element will be 28, so it is in the range between 25 and 30. But if my target element is exceeds 30, like 50, 60, 70, 80, then let me run this program. So error index outer bound exception, it is giving me exception. Why? So let's understand using debug. You will get a better understanding using debugging. Okay, so suppose, yeah, debug started, control stops on start. Next, so what is the start? Start is 0 and is 9. Okay, mid, what is the mid? So mid is 4. Okay, target is 50. Now 50 is greater than ARR of mid. What is mid? 4. ARR of mid is, select it, inspect, 12. Definitely 50 is greater than 12. Inside start equals mid plus 1. Okay, what is start? Mid was 4. 4 plus 1, 5. And is 9. Okay, again calculate mid. Mid is 7. Now target is 50 and ARR of 7, which is 0, 1, 2, 3, 4, 5, 6, 7, 21. Okay, you can also calculate the value by selecting, inspect, 21. 50 is greater than 21. Yes, again. So start equals mid plus 1. Fine. Now start is, mid was 7. So it's start equals 8. Mid plus 1, that is 7 plus 1 equals 8. Okay. And is 9. Is still condition true. 8 less than equals 9. Fine. What is the mid? Mid is 8. Okay. Mid is 8. Now target is greater than. target 50 and ARR of 8. What is ARR of 8? Inspect 25. 50 is again greater than 25. Okay, start equals mid plus 1. What was our mid? Mid was our 8. Okay, so start becomes 9. 9 less than equals 9. Yes, condition true. Okay, so what was our mid? Mid is 9. Fine. Target, which is 50, and what is ARR of mid? ARR of 9. So what it is? It is 30. Still 50 is greater than 30. Yes, condition true. Start equals mid plus 1. What is a start? Start becomes 10 and end is 9. Condition false. 10 is not less than or equals to 9. It comes out of the loop. Now what is the start? Start is 10. Start is 10 and our array can go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. What is the max index of our array is 9, and we are trying to find ARR of 10. That's why it is giving us index out of bound exception. So in that case, what we need to do is we need to add one condition here. Okay, if my target is greater than ARR of ARR dot length, okay, minus 1, that is the last element, then return, or in this case we are printing the element system.out.print and minus 1. Okay, because why? You can see here, what is this is the ceiling program. Okay, and what is the ceiling? Ceiling means the smallest number which is greater than or equal to target. Okay, in this case the target is 50, so that means it should lie here. 30, 40, and then 50. Okay, so smallest number which is greater than target. What is the target? 50 is the target. What is the max element? What is the the last element? As it is increasing order array. Okay, so it is the largest element, 30. Fine, it is the largest element, and we are trying to find out a number which is greater than 50. Okay, the smallest number which is greater than or equal to 50. It is not possible. Okay, definitely index out of bound exception. So in that case we can write here. Okay, now another case is if suppose 0, then in this case I am trying to get the access of the element which is also not present and which is less than my first element. What would be the output? Comment down what would be the output. The output should be 3. Why? Because ceiling definition is greatest number. Okay, smallest number which is greater than or equal to 0. There is no 0 in this. So what is the smallest number which is greater than? 3 is only the smallest number among this array which is greater than 0. Definitely 3 will be the answer. If you can just run it. Three. Okay, so in the ceiling if target greater than ARR of last element greater than last element, in case of increasing, in case of decreasing, it may change. Okay, it's upon you. Okay, I want you to do it. So this is for ceiling. Okay, now for floor the condition got changed. So for floor it should be and. Okay, now write 50 and then run it. 30. Okay, 30. We need to remove this condition because it is this condition is for ceiling, not for floor. Okay, so you can see it is not giving any exception in case of floor. 30, that is the last element. Okay, so it will be in floor it reverts. What is a floor means? Floor means the greatest number which is less than or equals to target. So 30 is only the greatest number which is less than 50. Okay, it is only the greatest number, it is the last one. But in the case of floor, if my target will be 0, then it will give index out of bound exception. See, index out of bound exception. See it. Why? Let's understand using debugging only. Okay. And I know you will already got it the point. Okay. So now, fine. Start and okay. So start is 0 and is 9. Mid definitely be 4. Okay. Target is 0. That means target is less than ARR of mid. What is ARR of 4? That is 12 definitely, and equals mid minus 1. Start is 0 and end was 9, so mid was 4 minus 1 3. Okay, condition is still true, 0 is less than 3. What is mid? 1. Okay, 3 by 2 is 1.5, so 1.5 in an integer, it is 1. Target is 0 and mid was 1. ARR of 0 1 5. Okay, 0 is still less than 5 and equal mid minus 1. Okay, what is mid? 1 minus 1 0. Start is 0 is less than equal 0. Condition again true. What is mid? Mid is 0 upon 2 is 0. Okay, target is still less than, because target is 0 and mid is again 0. ARR of 0 is 3. ARR of 0 is 3, so 0 is less than 3. Okay, condition true and equal mid minus 1. Now mid was and was 0. Okay, so and mid was 0, so 0 minus 1 minus 1, so and become minus 1 and start is 0. So 0 is less than minus 1. No, condition false. Okay, so it return ARR of end is minus 1. So ARR of minus 1, it is trying to access the negative index, which is not possible. That's why it is giving index out of bound exception. So in this case also, just write one condition: if my target is less than ARR of 0, return, not return, in this case we are just printing s out minus 1, else this. Get a point. Now run it. Minus 1. Okay, so this is what we have completed, ceiling and floor. Fine, now let's do a problem, a lead code problem. Yeah, so this is the problem. Okay, and this problem is asked in Facebook. And you know, Facebook questions are really tough. But I already told you that there is no medium, there is no hard problems. You'll see it. See, this is a medium category problem. Okay, but for me, it is very easy. It's very easy. Okay, so let's see it. Find first and last position of element in the sorted array. Okay, so array is given to us. This is the array and this is the target. And you need to find in O of log n. See, O of log n means binary search. Binary search, okay. Now let's take this example, 5777. Okay, 5 7 7 8 8 and 10, and our target is 8. Okay, so first and last position of 8, first position is this, last position is this, 0 1 2 3 4. Okay, 3 4. In this 6 is the target. Now 6 is not present, so therefore minus 1 minus 1. 0 is not present, minus 1 minus 1. Okay, so in this, how you will achieve it, how you will achieve this solution? Okay, so now array is given to us as, let's take our own array, 5 7 7 7 7 8 8 10 11 13. Okay, and our target is 7. Target, our target is 7. Okay, fine. Now the first position. Okay, what we are expecting, our answer should be, okay, 0 1 1 comma 0 1 2 3 4 1 comma 4. Okay, the first position of 7 is 1 0 1 2 3 4 5 6 7 8 and 9. So 1 and 4. Fine. Now how you will apply a binary search? Okay, how you will solve this problem in O of log n? O of log n time complexity, that is binary search only. Okay, fine. Fine. So binary search. Okay, so when you apply binary search, suppose you apply binary search on this array, and start equals 0 and equals 9. Okay, you apply the binary search, you have calculated mid element. Okay, so what is mid? Mid should be 0 plus 9 minus 0 upon 2, which is equals 9 upon 2, which is equals 4.5. Okay, which is 4. This is our mid. Okay, 0 1 2 3 4 4. Now you need to check if my target is less than, greater than, or equals ARR of mid. Okay, my target equals 4. No, my target is 7. Okay, and ARR of mid is 4. So ARR of 4 is 7. So it equals. Now what you need to do is, see, there is a two condition. If my target greater than, this greater than, if my target less than, if my target equals to, it becomes equals. So in the normal case, what we used to do is, we'll return this element, because we need to find, in normal case we need to find the index, but here we need to find the first index and the last index. Okay, so how we will find the first occurrence and last occurrence? Suppose if you get target equals mid, then what you need to do is, again apply binary search. Listen carefully. This is your mid. Okay, this is your mid. Now you need first occurrence. You need first occurrence. So how you will get first occurrence means, suppose if the element is found here in between. For example, we found our target element as index number 4. Okay, at index number 4, this is 0 1 2 3 4. Now there may be possible that there is another target element, that is 7, is exist before it on the left side of left side on the left side. Okay, if 7 is present, if there are more 7 is present on left side, then we need to check there also. Get my point? Okay, so in this case, we got target equals mid, we got a target element at index number 4, but we don't know that is there any more target element, is there any more 7 is present before it on the left side. What we need is, what we need, first position, first and last position. So what is the first position in this case? This is the first position, 1. Okay, so we need to check till here, till 0th index. But in this case, if we find if target equals mid, then we need to check in this array also. So how to check? Apply binary search here. Apply mid element, target equals this. Okay, you know my point? If target equal mid, okay, apply binary search here. Apply it. Again apply binary search. Calculate mid. What is mid? S plus and minus s upon 2. What is s? 0. What is end? Here end is 4. 4 minus s is 0 upon 2, which is 2. 2 is mid. This is our new mid. This is our new mid. Okay, this is our new mid. Now again check if target equals again check if target equals greater or less than ARR of mid. Yes, 7 equals 7. Then it may be possible that there is more 7 present before it. There is more 7 present before it. Okay, again apply binary search here. Again apply binary search here. Okay, then the start is 0 and end is mid, that is 2. Then calculate. Again apply, then calculate till you reach here. Get my point? So this is what we'll find the first occurrence, and same as last occurrence. Apply binary search here, apply binary search here till last. Getting my point? Are you getting what I'm saying? Huh? Okay, got it? Okay, in brief, suppose we have applied binary search. Okay, fine. We found this is the mid element. We have checked the condition. According to the condition, we found our target element as our mid element. Okay, then there may be more elements. There may be more target element present on the left side. Why? Because we want to find the first occurrence. We don't want to find the index of our target element. No, we know there are target element present more than once, so we want to find the first occurrence. Okay, what is the first occurrence? First occurrence means if we find the mid element, then we need to check in this the left side, because first occurrence definitely occur on the left side. It is an increasing order array, it is a sorted array. Okay, so how you will find the more target element? How you will find the more target element? How you will search? Using binary search. Okay, again do it. Again binary search. Again binary search. So what would be the time complexity? What would be the time complexity? Time complexity is, see, time complexity, once we apply binary search, log n, then log n, log m, okay, then log o, it is the actual size, then the size reduce, then the size reduce. Okay, so overall is some constant log n. We can eliminate this constant. Okay, constants are eliminated in time complexity. Overall time complexity is log n. Okay, so now let's break this problem step by step and write the solution on pen and paper. Okay. Fine. So this is our array. Okay, this is our array. Actually, I break in this 3 parts. Okay, one is our main function. Okay, which calls one method. Okay, the method is first and last position, some method. Okay, inside it we are passing this array. Okay, and our target element. Okay, this is our first main function, first step. Okay, second step, first and last position method where int arr and int target. Okay, fine. What you need to do is, in this again we are creating another method, helper method. Okay, which helps to get first and last position. Okay, helper position method. In it we are passing array, target element and false. Okay, why we are passing a boolean value? Don't worry, I'll clear everything. Okay, so this is what the second method. Okay, and in this we are taking start position and int end position. Don't worry, I'll explain everything. Okay, I explain everything. Helper, ARR, target, and false. Here it will be true. Okay, here it will be true. So this is the first method. This is the second step. We have created this method, and then we are calling this again method, helper position method. Why? Because helper position method get back with a value start and end. Okay, fine. Okay, fine. And we are just declaring our initial array int result array whose default value is -1 comma -1. Why? Because -1 comma -1 if target is not found. Okay, so default value is -1 comma -1. Okay, fine. So this is what our second. Now the main backend process, what is in the helper method. Okay, so helper position, what we are getting, int array. Okay, in target. Okay, and some boolean value. Boolean is first. Okay, okay, we will write just one method. Okay, so believe me, it's a really great example Facebook has asked. Okay, but super easy. Okay, so this is a helper method, and in the helper the same binary search algorithm is written. Same binary search algorithm that initially this is the array, and we will declare one variable, answer variable, which is value is -1. Okay, why? We'll get to know. You will get to know. Okay, okay. Start initially equals 0 and equals ARR dot length -1. Okay, okay, 0 and it is equals to 9. Okay, so this is our constraints. Fine, we will take extra variable answer which is equals -1, start is 0 and end is ARR of -1, that is 9. Okay, because length is 10. Fine, so now let's understand in a beautiful way. ARR is 5 7 7 7 7 8 8 10 11 13 10 11 13. Okay, this is our array. Fine, target is 8. Okay, now in helper position we need to write, in helper position we will write the same concept, same binary search algorithm, just we need to change few things. Initially we need to declare a extra variable answer which is equals -1. Okay, and this condition we need to change. Why? Because see, if target greater than ARR of mid, we will apply this condition. If target less than, we will apply this condition. Else, if target equals mid. Now we don't want to return the index of target element. There are 4 target elements. Our target is 7. There are 4 target element present. A target element present which is repeated 4 times. Okay, we don't want to return the index of target element. We want to return the first index and last index, first occurrence and last occurrence. That's why this condition is not valid. It is just returning the index. Okay, we will find this. We have applied binary search. Okay, we have found this is the our mid element. This is the mid element. Okay, we will return. No, we don't want this. We want an answer will be 1 and 4. 1 and 4. First occurrence of 7, last occurrence of 7. Okay, so now we have declared a variable. Fine. Okay, why we have declared this answer variable, we will get clear using debugging. And in short, I'll tell you that if suppose our target will be 100, which is not present in the array, then we will return answer in the array, 1D array. Why? Because you can see, because we need to return 1D array. What is this? 1D array, right? So therefore, okay, don't worry, we will get a clear cut understanding using debugging also. Okay, so this is, we have declare one variable, fine. And when we have applied binary search, how to apply? Calculate the mid. First we'll check the condition. So initially s equals 0 and equals 9. Okay, fine. S equals 0 and equals 9. Okay, condition true. Condition true. Comes inside, what is the mid? Mid equals start plus n minus start upon 2, which is 9 upon 2, which is equals 4.5, which is 4. Okay, it is our mid. Target greater than ARR of mid. Let's check if my target is greater, less, or equals ARR of mid. Let's check it. What is target? 7. What is ARR of mid? Mid is 4. What is 4? ARR 4, 7. Okay, target equals 7. Now we need to again check on the left side that is there any 7 present or not. That will be our first occurrence. Okay, so how to check? We will come here, because condition false, else. Okay, else part executed. So now here we will write ans equals mid. This ans, which is initially -1, okay, but now it should not be -1. Why? Because we found the element. Okay, so ans equals mid. What is mid? 4. Okay, fine. If see, we have used this boolean. We have used this in helper position. We have used one variable boolean. So what is the use of it? What is use of it? This is first. The use of it is, we will call the helper position. Okay, suppose we want the start index, then we will kept the value is true. If we want end index, we will kept the value as false. So what is the use of it? If we want start index, so we will kept the position, we will kept is position value as true. Why? Because see, initially now we are checking that is position. Okay, if it is true, then now listen carefully. If it is true, then and equals mid -1. Here 7 becomes equals 7. Okay, fine. What we are seeking, we want first index, first occurrence. If we want the first occurrence, that should definitely be on the left side. Okay, if it is on the left side, then this is our new end. We need to change the end as mid -1. Get my point? So we will change our end as mid -1. So the new end is this. Now apply again binary search. That means again calculate mid element, s plus e minus s upon 2. Okay, what is s? 0 only. What is e? 3 minus 0 upon 2, which is 1.5, which is equals 1. Okay, 0 1. So this is our new mid element. Fine, again check if my target, which is greater, less, or equals to ARR of mid. It is again equals, target is 7 and it is also 7. Okay, now again we will enter into this loop. Again now answer becomes mid. What is a mid? What is mid? Now mid is 1. Mid is 1. Okay, so now mid changes from 4 to 1. Okay, is position is true? Yes, because we are seeking the first index, and when we are calling this method, then only we will pass the value. See, we are calling this method int start, we are passing true. We are calling int end, we are passing false. So we are passing this is true. If this is true, then put end equal mid -1. Okay, so again, what is the end? End is 0 1 2 3. This is what is mid? Mid is this. Okay, mid -1. That means start equals end. Okay, start equals end, again check. So start is 0. Now in this case start is 0 and becomes 0. So 0 is less than equals 0, condition true. Calculate the mid, mid is also 0. So this is also becomes 0 because 0 plus 0 upon to 0. Target greater than ARR of mid. What is the target? 7, which is greater than ARR of mid. What is ARR of mid? What is mid? Mid is 0. ARR of mid means ARR of 0 is 5. Target greater than, okay, start equals mid plus 1. What is the start? Start initially was 0. So it becomes now 0 plus 1 because mid is also 0. So 1. Start equals 1. Okay, again comes here 1 less than equals 0. Condition false. It comes here and it is returning this. What is this? The value of answer. The value of answer was 1. Okay, the value of answer was 1. 1. Okay, so start element, first occurrence is 1. What is the first occurrence? 0, 1. What we need? 1. And the same thing will apply for 4. Okay, just we need to pass false here. If answer equals mid, okay. If position is false, because why? We need the last occurrence. Okay, so we will pass the is position value as false. Okay, if the is position value is false, then in the else condition start equals mid plus 1. Okay, so this is our new mid, this will be our first mid. We will calculate. Okay, we had already calculated after this. Okay, this is a new mid, 7 equals 7. Now it comes here. If is position false, it execute else part, else is mid plus 1. So start is now mid plus 1. This. So what will be the last value of ANS? Mid. What was the mid value? 4. 4. 1 4. Okay, and it is super easy. Okay, we will see using debugging also. I hope you will get clear cut understanding, but we will see using debugging, so you will again get a super understanding. Okay, fine. So how you will, because I haven't write this in the whiteboard, how you will get this? Let me do it like this, if it is possible. It's not taking complete. New page. It is fine, right? Hope you'll understand. Okay, let me suggest. Okay, fine. So now let's do the program. Okay. Okay. New class. What will be our class? Let me erase this first. Search range. Okay. Search range. So let's create for main method. Okay, let's go step by step. What we have written is initially main method, and first and last position we are passing array and target. Okay, main method, and let's create array which is equals to 5 7 7 7 7 8 8 10 11 13. Okay, target is 7. Okay, we are passing get me first and last position. Okay. ARR target. Fine. Static int, because why we are returning integer 1D array, because in the main question, in the main problem wants us to return integer 1D array. This is 1D array. Okay, that's why. Okay, first and last position, fine. Int ARR and int target. Okay, fine. Now let's create result array, and the default value is -1 -1. Okay, now we want start element, start and last, start and end. Okay, so helper position ARR target and true. Helper. Okay, int and helper position ARR target false. Okay, result of 0 equals start. If we got occurrence, then result of 0 equals start, else we got -1, because answer, initially the value of answer is -1 only. Okay, initially the value of answer is -1, so we will get -1 and that is what we want, right? Result of 1 equals, and okay, return result. Okay, fine. System.out.print arrays dot to string. Okay, why I'm using arrays.toString? Because we are getting 1D array, and to print 1D array in terminal system.out.println, we won't use arrays.toString, else it will print the hash code, it will print the object reference hash code. Okay, how? One square braces, that means 1D array, and I, that means integer array. Okay, I already told you the notations how to read 1D array reference variable. Okay, so this is what we have created. Now the final thing, static int helper, it is not coming. Helper position int ARR int target boolean is position, is first position. Okay, let's declare one variable ans equals -1, and rest all is same. Start equals, why I am writing it? Yeah. Okay. Okay, now the game plan. This is the game plan. ANS equals mid. Okay, if, we'll check if is first position, that means if we want start or end. If we want start, then there is some different condition, so we need to find we need to pass true, else we need to pass false. We are just checking. Okay, if it is, then and equals mid -1, else and equals, sorry, start equals start equals mid +1. Okay, return ans, one and plus. Okay, fine. Okay, let's run it. 1 4 1 4 8 0 1 2 3 4 5 6 5 6 5 6. Okay, if suppose an element is present only once, then start is that and end is also that. 0 1 2 3 4 5 6 7 8 8 8 8 8, because start is that and end is start and end both are same. 110 not present. -1 -1 -1 Okay, just we need is, let's copy this code and paste it here. Fine, we have saved it. Is there any, and in this function we just need to call this or just return it. Return this nums target. That's all right. Yeah, that's all. Okay, target target boolean false. Okay, let's run it. All test case pass. Let's submit it. Let's submit. Accepted. 0 millisecond beat 100%. 0 millisecond beats 100%. Okay, this is the medium level. Now see, is it medium level? Is it Facebook level? Is it easy level? Super easy level? Okay, so this is the problem we have solved. Okay, I hope you get the complete understanding. Okay, so now let's achieve you in debugging mode. 7. Let's put the debug point first. Okay, let's debug it. Control will stop here, and then we will execute each line and see what will be the output. Helper position, okay. What is ARR? ARR is this. What is target? Target is 7. Okay, 7, and it is true. It comes inside helper position. This is the helper position method. Find ANS equals -1. Execute the same way as binary search. What is mid? Mid is 4. Okay, target is 7. ARR of 4. What is ARR of 4? Inspect it and check it. ARR of 4 which is 7. Okay, 7 equals 7. 7 equals 7. Okay, in that initially ANS is -1, mid is 4, ANS equals 4. Okay, now is position is true. Why? Because we are finding first a starting index. Okay, is position true? If is position true, then end equals mid -1. What is the end? 9. What is mid? 4. 4 -1 3. Okay, now the new end is 3. The start is 0. Again condition true. Mid 1. 3 by 2 1.5, that is 1. Again because the first element also 7, that's why 7 equals 7. Now the answer, initially answer is 4. Okay, now the mid is 1, so answer become 1 because it updates that there are again a target element present before the 4th index. That's why we need to update it. We have updated. Yeah, is position true and equal mid -1. Okay, fine. And was 1. 1 -1 0. 0 0 equals 0. Condition true. Mid is 0. Okay, now this condition true. Why? Because target is 7 and ARR of 0 which is 5, so it is 7 greater than 5. Okay, start equals mid plus 1. What is the start? Initially 0. Now 0 plus 1 1, and is 0. 1 less than 0? No, 1 is greater than 0. While loop false condition and return answer. What is the answer? 1. Okay, so what will be the start? 1. First occurrence. Now and similarly, okay, comes inside, execute in the same way. Mid was 4. Okay, so answer equals 4. Fine, as mid equals 4 and it equals target. Here it is 4, so target equal ARR of mid. Now its position is false because we don't want the first index, so we don't want to check here, we want to check here. So to check here, we want to move our start index to mid plus 1, not the end index. Getting? So start mid plus 1. Okay, what is the start? Start 5 and is 9. Okay, calculated, it is 7. Fine. So target, what is the target? Is 7 and ARR of 7 is 10. Okay, it is less than and equal mid minus 1. Fine. What will be the new end? 6. 5. Again condition true. Okay, mid is 5. Fine. Target is 7 and ARR of mid. What is mid? Mid is 5. ARR of 5 is 8. 7 less than 8. Okay, again condition true. And initially is 6. Mid is 5. 5 minus 1, 4. Okay, and becomes 4. Start is 5. Condition false. What was the ANS we updated? As 4. Okay, it returns 4. What was the last occurrence of 7? 4. Okay, 0, 1, 2, 3, 4. Result of 0 becomes 1. Result of 1 becomes 4. What is the result? 1, 4. Return it. Okay, what we are printing? 1, 4. Okay, so this is what you need to debug. Debug is super great when you have any doubt, when you are just want to see, okay, where I am getting error and you don't know, just debug it line by line. Okay, fine. So now let's do another program. Okay, another, that is 2D array matrix that I have promised, row column and sorted matrix. Okay, let's do it. Okay, so now the next problem is 2D array. Okay, we have already done a complete dedicated video on binary search in 2D arrays. If you haven't watched it, then please watch it, and in that I have given you a task to solve the problem that we have discussed there. Okay, row column matrix. Fine. And see, I have divided the problems of binary search in 3 parts. Okay, because it becomes 6-hour long video. 6-hour long video, so I have divided in 3 parts. First is easy to medium level, second is medium to hard level, and the third is hard to hardest level. Okay, so this is what the problems of binary search, and we will get the intuition and confidence building happens, okay, in binary search. So now let's discuss this problem. Ten, 20, 30, 40, 15, 25, 35, 45, 22, 32, 42, 52, 62, 73, 73, 83, 98. Okay, our target is 42. Okay, this is our target. Fine, we have already discussed that. Let's first, we need to consider it as a lower bound and it as a upper bound. So now let's check, let's take this lower bound as row and it as column. Okay, row and column. Why? Because we need to traverse. Lower bound is traversing from here to here and upper bound is traversing from here to here. We have already discussed now that, okay, suppose my target, okay, is greater, then we need to eliminate row. So lower bound is eliminating here, 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 and then max to max length. Why? Because lower bound is traversing row wise and column is traversing column wise. We've already discussed in the video that okay, first we need to first starting from upper bound. Okay, starting from upper bound, initially lower bound is 10 and upper bound is 40. Okay, upper bound is 14, lower bound is 10. So let's consider this as a row and this as a column. So if ARR of row and column equals target, then return index. What is index? Row and column. Fine. If not, if suppose ARR of that is means upper bound, row and column, okay, is greater than target. What is the ARR of RC? What is R? 0. What is C? Upper bound. What is upper bound? 0, 1, 2, 3. 1, 2, 3. 0, 1, 2, 3. What is upper bound? 3. So what is ARR of RC? 0, 3. That means this value, this element. And what is target? 42. So what it is? It is less than only, na? See, we are checking the same. What is the binary search? Equals, less or greater than. Okay, so just we are checking from upper bound here. What is this coordinate? This coordinate is what? 0, 3 only, right? What we are written here? AR of RC. What is R? We have taken lower bound. What is lower bound? 0 initially. What is C? Upper bound. What is upper bound? 3. So AR of RC is greater, less or equals? It is not equals. It is greater. 40. Target is 42. It is less than. If it is less than, then all the elements before it is less than. Why? Because it is in row column matrix, sorted in row wise and column wise. Okay, so if my this element is less than, then all these elements are less than. Why? Because it is sorted and this is the last element. So if these all elements are smaller, then we can eliminate this complete row. We can eliminate. So lower bound comes here, upper bound comes here. Okay, that means this row got eliminated. If this row got eliminated, so what it means? It means lower bound is traversing row wise, and suppose this is the element. In the next case, we will again check if ARR of R comma C is greater, less or equals than target. So if now this row got eliminated, now again check that AR of RC. What is AR of RC? 45. What is target? 42. Now it is greater. If it is greater, okay, if it is greater, then we will eliminate the row, because eliminate the column, because all the elements is greater than. So there is no need of checking that. Eliminate this. It shifted here. Okay, then eliminate this. It again shifted here. This also this. Then it equals. If it equals, return R comma C. Simple. Very simple. Okay, fine. So okay, so now let's do the program. Okay, search search in 2D. Just write it. Search in column matrix. Okay, so what we need to do is, first let's create main method. Okay, then let's create one function. Okay, we will create later we'll create later on. Okay, so what it is returning? It is returning integer 1D array and search method 2D array. Okay, and target. Okay, now fine. So we have taken int upper bound, lower bound. Okay, so we have taken lower bound as row, which is equal 0, and int upper bound as column, which is equals ARR dot length minus 1, fine, 0, because it is a column. Okay, while r less than ARR dot length and c greater than equals 0. Why I put this condition? Because you can see here, this condition, because c, r is traversing from 0 to ARR of length, and c is traversing, this is the c upper bound is traversing from up to 0 equals to 0. Okay, so this will be our final condition of while loop. Okay, where lower bound, which is r, should be less than ARR of length, and column, which is upper bound, should be greater than, that is 3, 2, 1, because see, we are eliminating 0th, 1, 2, 3rd, at the end 3rd, so it should not be greater than ARR of length. Okay, and in the column case, 3, 2, 1, we are eliminating column, so 3, 2, 1, so it should be greater than or equal to 0 at the end 0th. Okay, this will be our final condition. Okay, so this is the condition. Now if ARR of R and C is equals target, then return new int of R comma C. Why? Because you can see here, suppose initially our lower bound, that is R, is at 0 and upper bound, that is column, is at 3. Okay, now initially we have checked that 40 is less than, okay, we have eliminated the row. Now the 45 is greater than, we have eliminated the column. Okay, so C, initially R here, C comes here. Okay, then column eliminated. Okay, so C comes here, so initially C is 3, now C become 2. Okay, then again this upper bound is less than, so again we have eliminated the row, so now R comes here, so this is the new R, and this is the new C. Now when C reaches here, so it is what, it is target element, that means ARR of R and C is equals to target. Okay, so that means if ARR of equal target, then we need to return an array which contains 1D array which contains R and C. So that is what we have done. We have created 1D array, okay, with the value R and C. Okay, now if ARR of R and C is greater than target, so if ARR of R and C this is 40, this is 45. Okay, 55, 52. Okay, so in this case 45 is greater than target. So if any element is greater than target, then we are eliminating the column. Okay, if any element is less than target, suppose 40 is less than, so we are eliminating the row. So in this case we are checking if element is greater than target. For this 45 is greater than 42, so we are eliminating the column. See, initially column is at 3, upper bound column is at 3, so we are eliminating how? C minus minus. So now the new column is 2, initially it is 3, now C minus minus. And if my element is less than, then we are eliminating the row, that means R plus plus, initially R is 0, so plus plus 1, 2, 3, and in case of C, 3, 2, 1, 0. Okay, so see, what I am explaining, that only I am implementing. Okay, C minus minus, simple, else R plus plus. Okay, return new int -1 comma -1. This is for if the element is given to us, the target element. Okay, target element is not present in the matrix, then minus minus. Now just last step remaining, that is creating a 2D array. Ten, 20, 30, 40, 15, 25, 35, 45. Okay, 22, 32, 42, 52, and 62, 73, 83, 98. Okay, and target, which is 42. Okay, 42 only, right? Now we are calling initially arrays dot to string. We are calling this. Okay, fine. So we are calling it. Let's run it. 42. Okay, 22, 42 is 012, 012, 22. Okay, correct. 20, 20 is 01, 01. Okay, 98, 98 should be, it is ARR of 0. Okay, see, this is the column. Initially it is 4 into 4 matrix, n into n. Okay, matrix can be n into m, like there is 3 column and 2 rows. 4 into 5, 5 into 3, 3 into 5. So ARR of 0. Okay, so before it you need to just add a check. Okay, let me keep it for you. Okay, because if the array is null, then it can give an exception, null pointer exception. Get my point? So just check that array is not null. Okay, let me do it for you. Okay, first let me see, let us see this program. So 98. Okay, save it. 33, 0123, 0123. Okay, if okay, if array equals null, then this. Okay, so now let me give you 198, which is not present in the matrix. -1, -1, -1, -1. Okay, now let me give null. -1, -1. Okay, so now let me remove this, comment it. Now let me run it. See, exception, cannot load object, ARR is null. Okay, and the line number is 16. See, it gives an exception. That's why you need to add this check. Okay, now let's debug it. Controller stops here. Oh, array is null. Fine, if array is null, okay, enters it and then print the output. Fine. Okay, fine. 42, right? Let's 42. Okay, all fine. Let's debug. Control it stops here. Fine. Array is null. No, array is not null. AR 0. R is 0 and C is 3. C 0 1 2 3. C is here. C is at this point and R is at this point. This, okay. Now R is less than AR of length. Okay, 0 is less than and C is greater than. Fine. Now if ARR of RC, that means 0 and 3 is equals target. Let's check. No, ARR of RC is 40. ARR of R is 0 and 3 C is 3. So 0 3 is 40. Okay. Target is 42. No, it is not equals. It is greater. No, 40 is not greater than 42. Else R plus plus. Okay. So now it comes here. Okay, it we have eliminated this row. Okay, fine. Now let's again check if R is 1 and ARR dot length, so is this condition true and C is greater than equal to 0. Okay, fine. If ARR of RC, now check what is ARR of RC. 45. See, that means the control comes here. We have eliminated this row. 45 equals target. No. 45 greater than target. Yes. C minus minus. Okay. Now this column also eliminated, this last column and first row. R is 1, condition true. C is 2. Okay, initially it is 3. C minus minus 2, condition true. Okay, now what is R? 1 and 2. So if ARR of 1 2, ARR of 1 2 which is 35 equals target. No. ARR of greater than target. No. Else R plus plus. So we eliminated this row also. Okay, if we have eliminated, then R comes here and we have eliminated the last column. So C is here and R is here. That means 2 2. So R is 2, C is 2. Okay, ARR of 2 2 which is 42. Okay, and target is 42. So it is equals. Yes, it is equals. Create the new array, return it and then print it to 2. Similarly, you can take anything. So this is what we have done matrix. Okay, so this is what all about. This is the part 1 of the video. This is the part 1 and the rest videos. Okay, another sorted matrix plus. Now we are heading to the medium problems, medium to hard. So which is another 2 hours. So which I'll be covering in the next video. Okay, I know it's been getting very delayed, but there's some problem arises. Okay, but from now I'll try my best that I will publish the video in 1 to 2 day gap. Okay, so this is what all about this video, and if you like, then please subscribe, share and comment down. Please comment down. Comment is necessary. Okay, so let's meet very soon in the next problem of search, and then we'll complete these problems. Why I'm taking so much time in problems? Because this is only what you will get asked in interviews. By reading theory, okay, you can done it, but without solving the problems, you'll not get any confidence. So how you build the intuition? That's why problems videos are very serious, and you should focus. Okay, focus. Okay, so let's meet in the next video and solve the problem, and then over this topic. Okay, then sorting and then recursion. Fine. Okay, thank you and have a nice day.